Hi everybody, this is Mrs. Dunn. I wanted to talk to you today about estimating a population standard deviation or variance using the chi-squared distribution. So what I'm going to cover in this screencast is I want to briefly introduce you to the chi-squared distribution. I want to teach you how to use a chart to find the critical values of the chi-squared, the critical value on the left and the critical value on the right. I want to teach you how to construct a confidence interval for a population standard deviation. We're going to do that two ways. We're going to do that once with statistics, and we're going to do that once with data. So here is an explanation of the chi-squared distribution. I got this from your book, and you can read through this. Feel free to pause this video and read through this screen. But I just want to highlight a couple key points from here. The first thing I want to highlight is that once again, we're going to be using degrees of freedom. You remember we used this with the student T distribution. Just like the student T distribution, the chi-squared distribution is going to change depending on the degrees of freedom. And just like before, the degrees of freedom here is going to be the sample size minus 1 and minus 1. I also want to point out that the chi-squared distribution uses this formula. The sample size minus 1 times the sample standard deviation divided the sample standard deviation squared divided by the population standard deviation sigma squared. Because of this formula, n minus 1 can't be smaller than 0, and s squared divided by sigma squared is going to be close to 1. So the chi-squared is never going to be smaller than 0. And you can see that in this graphic, in this illustration. So in this figure, you'll see also that the chi-squared distribution is not symmetric. It starts at 0. That's different than the normal distribution and different from the student T. What also is different is that it's not symmetric. And if you'll remember that the shape is dependent on the degrees of freedom. Okay, so let's talk about how we're going to find critical values. Let me read through this example. So a simple random sample of 22 IQ scores is obtained. Construction of a confidence interval for the population standard deviation sigma requires the left and right critical values of chi-squared corresponding to a confidence level of 95% and a sample size of n is equal to 22. Find the left critical value of chi-squared, separating an area of 0.025 in the left tail, and find the right critical value of chi-squared, the critical value of chi-squared separating an area of 0.025 in the right tail. So here's the key information we have here. The degrees of freedom is 21. Remember, the sample size is 22, and 22 minus 1 is 21. So the degrees of freedom is 21. You also want to note that we need a confidence level of 95%. That makes alpha 0.05. So in the two tails, the tail on the right and the tail on the left, that area is going to have a total of 0.05. And half of that is 0.025. So that's why they're talking about an area of 0.025 in the left tail and an area of 0.025 in the right tail. You can see that in this illustration. So the area in the left tail is 0.025. That makes the area to the right 0.975. And the area in the right tail is 0.025. So this area to the right is 0.025. The critical values are written here. I'm going to show you on the next couple screens how you will find those using your table. So the key information is that the degrees of freedom is 21 and half of alpha is 0.025. So since the degrees of freedom is 21, we're going to go to that row in the table. I couldn't put the whole table on this screen. It would just take up too much room. So I've abbreviated it. I'm showing you the top. I'm not showing you the stuff that's in the middle here. And I'm just showing you these lines because that's what we need. We have a degrees of freedom of 21, so I need this row. So when you do it yourself, the whole table is going to be in front of you. So make sure you go to the right row for the number of degrees of freedom. So the degrees of freedom for me are 21. So that's the row I'm going to go to. I'd like to note something before I move on and talk about this. If you're looking at this chi-squared distribution, the chi-squared distribution has all the degrees of freedom up to 30. And then it jumps to 40, 50, 60, 70, 80, 90, 100. That's the ones that you'll see on the table that is provided for you when you're doing the homework or if you're looking in the book, and also in the table that will be provided for you on the final. So let's say you had a sample size of 67. And then your degrees of freedom would be 66. You will not see 66 in this table, so you're going to go to the next lowest, which would be 60. So if the sample size, or I'm sorry, the degrees of freedom are not showing, go to one less. Now that doesn't apply here because the degrees of freedom is in this table. So the degrees of freedom of 21, and we're going to look in this row. So we want the area. Let me toggle back to that previous screen. So the left side, the left critical value of the chi-squared is where the area to the left is 0.025. But this table is set up that it's showing us the critical value for the area to the right. So if this area is shaded in green right here is 0.025, the area to the right of that is 0.975. So the column is 0.975. The row is 21, and that value is 10.283, and that's the critical value on the left. The critical value to the right, let me go back to that screen. The area to the right of this critical value is 0.025. So the area to the right is 0.025. And the degrees of freedom are 21. So the critical value on the right is 35.479. So that's how you use the table. Okay, next let's talk about how to construct a confidence interval. And we're going to do that using statistics. So here's another example. So from that data set, there's a list of IQ scores for subjects in 3 different lead exposure groups. The 22 full IQ scores for the group with medium exposure to lead. Group 2 have a standard deviation of 14.29263. Consider the sample to be a simple random sample and construct a 95% confidence interval estimate of sigma, the standard deviation of the population from which the sample was obtained. The formulas are listed here for you. So this is the formula for the variance, sigma squared, and the formula for the standard deviation, sigma, is just the square root of each side. So n minus 1 is the degrees of freedom, S squared is the sample standard deviation, and the symbol x2r over here on the left is representing the right critical value of chi-squared, and x2l is representing the left critical value of chi-squared. So from this example, the n is equal to 22, so our degrees of freedom are 21. The sample standard deviation is 14.29263. That's all information that was given to me from the table. So we have the same confidence level, 95% from before, and we have the same degrees of freedom. So remember, the critical values are 35.479, that's the critical value on the right. and 10.283 is the critical value on the left. And I'm simply going to plug those in the formula. So let me show you how to do this on the calculator. The answer is written here, rounded to 1 decimal place. So let me show you how we would do that on our calculator. So on the calculator, I'm going to do 21 times 14.29263. I'm going to square that value, and I'm going to divide that by the critical value on the right, which was 35.479. And I'm going to press enter. Now, remember, that's the answer that I would get for the variance. I don't want this number. I want the square root of that. So to get the square root of that, I can simply press the square root, and it's going to take the answer that I had on my calculator. Notice I didn't type anything except that caret. And then I'm going to raise this answer to the 0.5 power. Remember, 0.5 is the same as raising it to the 1/2 power, which is the same as taking the square root. So the number you get for the left side of this interval is 10.996, etc. Rounded that to 1 decimal place, that would be 11.0. Now, I will need to do the same thing to the other side, except instead of dividing by 35.479, I want to divide by 10.283. On the newer calculators, you can go up to what you just typed, and you can change that. So we're going to change that value from 35.479. Let's change that to 10.283. Press enter. Remember, I don't want this answer. You have to remember to take the square root. Don't forget that. And then we'll take the square root of this answer. And that's where 20.4 comes from. Okay, now let's go through another example where we're doing this information. We're constructing this confidence interval from data. So, in a study of speed dating conducted at Columbia University, male subjects were asked to rate the attractiveness of their female dates, and a sample of the results is listed below. Construct a 95% confidence interval estimate of the standard deviation of the population from which the sample was obtained. All right, what do we know? Well, we know that the sample size is 12, so the degrees of freedom are 11. We know that alpha is 5%, so that means half of alpha is 2.5% or 0.025. We're going to use that information to find the critical value on the left and the critical value on the right. Pause the video if you'd like so you can practice this on your own and see if you can identify the two critical values that you need. Hopefully you found 3.816 for the critical value on the left and 21.920 for the critical value on the right. Okay, now we need the sample standard deviation S. So to find that, we have to use the information and what we learned before the midterm. What we have to do is go back and find this sample standard deviation. So just like we did way back in, I think it was chapter 2 or 3, we're going to put that information in our calculator. I've put those data values in list 1. After you put that in there, you're going to quit out of that and tell your calculator to calculate the one variable statistics. And you find out that the sample standard deviation is 2.2156, etc. So we'll round that to 2.216. All right, now I have the sample standard deviation, I have my two critical values, and that's the information I need. I also know the degrees of freedom to construct the interval. So once again, I'm going to use this formula. And when I put the information in the formula, I get a confidence interval rounded to 1 decimal place, 1.6, and 2, 3.8. So we are 95% confident that the population standard deviation is between 1.6 and 3.8. All right, good luck, everyone.